Hey guys, welcome back. We got number 7. It says the volume, or this is the volume. It says the hydrogen oxygen fuel cell is described in section 19.6 of the current textbook. Well, it gives us some reactions. It gives us, for the fuel cell, O2 gas plus 2 waters plus 4 electrons gives us what? 4 hydroxides. And that cell potential is 0.4. And then for the reduction part, it gives us 2H2 gas plus hydroxide, 4 of them, going to 4 waters and 4 electrons with a cell potential of 0.83 volts. So that's an overall reaction of 2H2 gas plus O2 gas, giving us 2 waters with a cell potential of 1.23 volts. All right, a couple questions here. What volume of H2 stored at 25 degrees Celsius at a pressure of 155 atmospheres would be needed to run an electric motor for 8.5 amps for 3 hours? Okay. All right, so now we need to figure out a couple things. If we have for A, 3 hours, we know that is 1 hour is 3,600 seconds, and that we know for every 1 second there's 8.5 coulombs. That's the amps, or A. So that means our total charge would be 3 times 3,600 times 8.5. 91800. All right, so 91,800 coulombs. All right, so that's our coulombs. Now, we want the amount of hydrogen, right? And so we know that 91800 coulombs, we know that what? 96,485 coulombs is 1 mole of electron. And then we can know that there are 4 moles of electrons, right, in this reaction, 2 moles of H2, right? And so let's see. 645. I'm getting 0.4757, which is too many sig figs, so we have, how many? We probably have right now 2. So 0.476 moles of H2. All right, so that's the moles, but now we need the volume, right? So we got to use PV equals nRT, and we got to solve for V. So volume is going to equal our pressure of 155 atmospheres on the bottom, right? Our moles would be 0.476. R 0.08206 liters atmospheres, moles Kelvin. And our temperature was 298 Kelvin. I'm assuming at this point we got that. All right, let's see. So 0.476 times 0.08206 times 298 divide 155. 0.075. 0.075 liters of H2. Neat. All right, so that's A right there. Hopefully that's makes sense to you guys. If you, obviously, reach out if it doesn't. B, what volume in liters of air at 25.1 atmosphere would have to pass into the cell per minute to run the motor? Assume that air is 20% oxygen, gas by volume, and all the oxygen is consumed. And everything else is great. Okay. Wow. Into the cell per minute. Ooh. Per minute to run the motor. Oh, wow. Okay. Well, let's see. So for B, we're starting with 8.5 coulombs, right? 8.5 coulombs per second. And we know that 60 seconds is 1 minute. So 8.5 times 60, 510 coulombs per every 1 minute. So that's how many coulombs per minute we need. All right. So we take our 510 coulombs per minute. All right. And let's see. We know that there's 96,485 coulombs per what? 1 mole of electron. And now we're in moles of electrons, right? And so there happens to be 4 moles of electron to every 1 mole of O2, correct? Yep, that's what the ratio is in the reaction. All right, so let's see. What do we have here? 510 divide 96,485 divide 4. I got 0.00132. Moles of O2 per minute. All right. Let's see. PV equals nRT again. And we're solving for volume, of course. So the volume would equal N. We have 0.00132 moles of O2 per minute. 0.08206 liters atmospheres. Moles Kelvin. 298 K. And the pressure is what? One atmosphere. All right, so 0.00132 times 0.08206 times 298. I get 0.0323. Three what? Liters per minute. All right, so now that's how much liters of O2, right? Of O2. But we now need to know it's not going to be just that, right? Because it's air. That's how much O2 we need per minute. So air is what? Well, it was 20% oxygen. All right. So let's take this 0.0323 liters of O2 per 1 minute. And we're just going to convert the liters of O2. So we know that liters of O2 to liters of air. So what's our ratio? If I have 1 liter of air, right? If we come back up here, it's 20% oxygen. That means I would have 0.20 liters of O2 for every 1 liter of air. I think that's going to give us a right answer. We're just leaving the minute there. So 0.0323 divided by 0.2, I get 0.16. 0.16 liters of air per 1 minute. All right. So let's recap. Let's recap everything we had. So we got the hydrogen oxygen fuel cell. That's what's going on with the hydrogen oxygen fuel cell. Okay. First question. What volume H2? Well, we figured out 3 hours how many coulombs need to pass through. What's the total amount of charge? Because we got the amps and we got the time. So we took our coulombs, Faraday, that's the moles of electrons to moles of H2. And we figured out how many moles of H2 we needed. And then we used the PV equals nRT right here to get liters of hydrogen gas. Right? So that's what we would need for 3 hours. Then we figured out liters. We wanted, instead of doing a coulombs per second, we did coulombs per minute, right? Because we're looking for how much oxygen, how much air, basically, per minute do we need to run the motor, all right? So we took our coulombs per second, made it coulombs per minute, and our coulombs per minute, we just kept this 1 minute, right, throughout. So you could actually drop the minute if you really wanted to and just put it in at the end. So then again, this is Faraday constant. It's 4 moles to 1 mole, electrons to moles of oxygen. So we got the moles of oxygen per minute. Use the ideal gas law again to get how many liters of O2 per minute. And then since we were in liters of O2, we went liters of O2 to liters of air, and that's all we did. If you have questions, reach out. Otherwise, we will see you next time, guys. Take care.